Hi, I'm Carmen Andoh, Open Source Strategy Lead for the Go team at Google. I'd like to talk about crossing the chasm, or Go, for the next million users. Most statistics show Go's global developer population has reached an estimated 2 million. This is almost double in 2 years. What does Go's growth mean for us, individually and collectively? And what calls to action must we take for everyone to be brought forward? What are the most pressing needs of our industry and our world? And how can we meet them with Go? I'd also like to talk about the Go ecosystem and the 2020 developer landscape, new challenges for tech and language ecosystems in the decade ahead. Let's get started. How does Go as a programming language succeed and thrive in the next decade? In the past, I and countless others have highlighted many technical merits, but I've come to learn that humans make emotional decisions. I'll spend this talk arguing why that is the case, and where do we go from here. To understand, I'll start with an old joke. A programmer is asked which language she thinks people will be using in 30 years. She replies, "I don't know, but it'll be called COBOL." I mention this COBOL joke because of what happened in May this year. Due to the pandemic shutdowns in the US, 20.5 million jobs were lost, an order of magnitude that this stunning New York Times front page infographic captures, with the right side image showing monthly change in jobs since 1946, and the negative change in orange going the full vertical spread of the print version of the paper. Why does this matter? Well, various states relied on COBOL software to manage their unemployment claims. Americans who were living paycheck to paycheck in those states were now dependent on old COBOL programs. But to some, COBOL is not the ideal language. If it were up to Dijkstra, this shouldn't be the case at all. As he says, the use of COBOL cripples the mind. Its teaching should, therefore, be regarded as a criminal offense. But COBOL here gets the last laugh. Languages don't get adopted and used because Dijkstra praises or insults them. There's a couple of things to learn from the events of the past year about what it takes to make a language succeed and thrive. The first is from this Brian Kernighan quote. Most languages don't die, or at least once they get to a certain level of acceptance, they don't die. As we've discovered with the COBOL incident, processing state government unemployment claims. Another way of saying this comes from Ari Robkin. Any language with legacy code will last forever. Rewrites are expensive, and if it's not broke, don't fix it. To the point where don't fix it will last decades. This is what is called the switching cost, where the cost to switch outweighs the cost of the status quo, or staying the same. There may become a breaking point, but until then, there's a bias towards the status quo. This bias towards the status quo has other names. My talk title, Crossing the Chasm, is taken from the 1991 book from Geoffrey. It posits that most technology adoption follows a curve like this. Enthusiasts make up the innovators and early adopters on the left-hand side. Then there's a chasm where adoption often stops and doesn't proceed. The chasm gets crossed once something gets used by the mainstream market, which is categorized as early majority, late majority, and laggards. Attitudes towards adoption are labeled as pragmatists, conservatives, and finally skeptics. For programming languages in particular, one factor in crossing the chasm is overcoming switching costs or reach a status quo. But how does it do that in the first place? Moore's book is based on an earlier book from 1962 called Diffusion of Innovations from Everett Rogers. This book has been cited over 40,000 papers, and proven via thousands of studies. It is perhaps one of the greatest business books of all time. Diffusion of innovations is a theory that seeks to explain why, how, and at what rate new ideas and technologies spread. Rogers argues that diffusion is the process by which an innovation is communicated over time among the participants in a social system. The origins of diffusion of innovations are varied and span multiple disciplines. Rogers' theory states that 4 main elements influence the spread of a new idea: the innovation itself, communication channels, a social system, and time. This process relies heavily on human capital. The innovation must be widely adopted in order to self-sustain. And within the rate of adoption, there is a point at which an innovation reaches critical mass. Looking further into these elements as they pertain to Go, the innovation is obvious. It's Go as the programming language and toolchain. Communication channels include things like golang.org and Go's newer site, go.dev, social media, aggregators, blog sites, Gopher Slack, the dozen of Go conferences worldwide, and so on. The last bit, the social system, are the operating and social contexts that the world moves in. This constantly shifts from year to year, but the key bit here is that the broader social system is what counts when we talk about adoption, not necessarily technical superiority. The easiest to understand elements are the outer ends, which is innovation and time. So I'm honing in on communication channels and the social system just to make sure that everyone is clear on what they are. The communication structure determines how messages may flow through the social system, for example, by providing communication links between individuals. A social structure influences diffusion through values, norms, roles, and hierarchies. I'll talk more on communication and social systems in just a bit, but let's return to our crossing the chasm. I just talked about switching costs and status quo, and I would argue that Go has already crossed the chasm because now it is in production systems and powers much of cloud, containerized systems, infrastructure, you name it. But in terms of users, teams, companies that are still looking to choose Go instead of inherit Go, how have we crossed that chasm? The answer lies in the mainstream. When it comes to Go and choosing a programming language for the task at hand, who is the mainstream market? Who are the pragmatists, conservatives, and skeptics needed to be won over when it comes to Go? Well, one answer is professional developers using it at work. A large subset of this includes enterprise developers in all different kinds of industries. I'm not the first to identify this as a mainstream market for a programming language. Let's take a look at the case of Haskell. Philip Wadler, one of the creators of the functional programming language, wrote a paper 2 decades ago called How Enterprises Use Functional Languages and Why They Don't. And his nugget of wisdom was, have you used it in anger yet? What does he mean by that? Well, as he says, the time is a dozen years ago. My fellow postdoc has just scrutinized my new bike. He's admired the chrome, checked the gears, noted the kryptonite lock. Now he wants to know if I've used it to serious purpose. Gleaming chrome is all well and good, but will it run you through the woods? Have you used it in anger yet? Mathematical elegance is well and good, but will it run that mission-critical system? COBOL does run mission-critical systems, and now so does Go. To get to the how, Wadler cited this angry half dozen, or 6 things that pass the test of using a programming language in anger, or qualities ready for the enterprise. I've mapped them here to fit the main elements of diffusion. To be widely used, language should support interlanguage working, possess extensive libraries, be highly portable, have a stable and easy to install implementation, and come with debuggers and profilers. However, many modern languages have all this as part of their innovation. So by these definitions, almost all programming languages in modern times are enterprise ready. The real differentiating factors aren't in the innovation itself for diffusion. The sixth factor, according to Wadler, is that the language should be accompanied by training courses, which squarely fit into the concept of communication channels. But then he added a bonus seventh factor: have a good track record on previous projects. This seventh factor, according to Wadler, is probably the hardest part and the missing piece. He calls this piece the need for a killer app. This killer app, while it can and has been listed under innovation, in the case of using it with Go as the coding language, I'm putting it squarely here in the social system. Let's look at why. I promised in my talk title that we'd look at how other languages cross their chasms. So here I go. Briefly, I'll list here killer apps for some other programming languages. Python's killer app, Zope, but also a killer project like Django. Rails for Ruby also fits into this category. Rust, Servo. Go, Docker, and Kubernetes. Kotlin, it wasn't an app, but rather Android compatibility. Before that, it was a niche language and not being picked up much. I want to caveat that this killer app pattern doesn't hold for every language, notably Java and PHP. But what a killer app does do is jumpstart proof of viability for a given programming domain. And it's this proof of viability that turns the tide. We can shout from the rooftop about Go's great features, but until someone is using it in real life and that app is a resounding success, that signals to other developers, teams, and decision makers, hey, it worked for so-and-so, that's proof enough for me. One could argue that this is a technical proof, but really it's a social proof, external factors outside of the innovation. It's what Dave Cheney in the Go community has called looking left and right to see what others are doing to making that decision. We see growing examples of how social systems play into diffusion and adoption, and some of you may still need more proof, so I'm about to give it to you. 9 years ago, 2 PhD students devoted 2 entire years to answering programming language adoption in an empirical way. They looked at 200,000 SourceForge projects and over 500,000 tracked by Olo. This was before the GitHub era. And then they held multiple surveys of 1,300 programmers. This paper would go on to win the OOPSLA 2013 Paper of the Year. I heartily recommend it a read. What they found is that of all the factors of innovation that happen for programming languages and why people choose them, extrinsic or social factors dominate. When it comes down to it, looking left and right, whether that it is familiar to others, or searching for open source packages, or extending existing code that others have already written in that language, these were far greater factors than safety and correctness, simplicity, or even performance. Take a look at the upper right-hand square and the black bars at the bottom of each grouping. When it comes to company size, extrinsic factors matter even more to larger enterprises. Even the outlier 2/3 down the list, potential team familiarity, is also a social factor. Why this matters? Social factors, not technical, primarily determine diffusion into the mainstream. Status quo and inertia will entrench you once you get there. And this means that diffusion and adopters and adoption is largely in the hands of the adopters themselves after that chasm has been crossed. So, what's next to be done for Go? How can you, as my fellow adopters, help? First, you've already helped us to know how to help. Go is an open source language, which means people can view all the source, but also they can participate in making the language better. The annual Go survey is ending today. This gives us concrete things that we know need to be improved. Let's run through an exercise on how we look at the challenges and what we can collectively do to improve them. This is from the annual Go survey from 2019, a year ago, answered by over 11,000 developers. To understand what diffusion element to help us towards a solution, I've added this diffusion element next to the challenge. The Go engineering team has spent a lot of time improving innovation, or the language and the tool chain itself, to meet the needs of developers and solving these biggest pain points. You'll have seen the keynote already by Robert Griesemer on generics. Next, we look at a social system that exists to help you, your team, your manager, CTO, and company look at the ways that Go has succeeded. For that, we have Go.dev, a hub launched a year ago. In particular, Go.dev has published almost 24 case studies from companies in many different industries. These are excellent examples for proving group familiarity, potential team familiarity, and recognizing a strong ecosystem. Package.go.dev, or Go's newly module-aware package discovery site, is a place to search for thousands of third-party and standard library packages and modules. This is perhaps the biggest and best example of looking left and right. The Go Discovery package site gives information about who used your package and what other packages that this particular package imports. That's a lot of packages in one sentence. It also shows the licenses that it uses. This will give you, your team, the people you're trying to convince to use Go, even your security compliance teams, confidence in the Go ecosystem. And that is table stakes for any programming language that wants to be chosen by enterprises today. We've spent a lot of time improving the social system and biggest external factors that enterprise developers and teams care about when choosing Go. Which leaves us with these remaining three: working with modules, issues with tooling, and the learning curve and best practices. I put these in the communication channels of diffusion, or if you remember, content and messaging that may flow through the social system, providing communication and learning links for and between individuals. Go has historically had a few channels to help, and in different ways. Golang.org, which has all our reference documentation and authoritative technical content. But it also has the Go Tour at tour.golang.org in order to check out the different features of the language. It also has the Go Playground, which is an interactive environment to explore language primitives. This is work to help people quickly get a grasp of the language, but the Tour of Go and the Go Playground need interactivity. This is particularly the case with beginners, because knowing the basics of the language, its syntax, won't help you if you can't learn how it works in a development environment or in a workflow. So we run into a chicken-egg problem, because if you're fighting your environment at setup, you're likely to quit even before you start. Also, tooling like your editor, your debugger, static checker, fuzzer, they're not included in the Go Tour, and nor can you experiment with them on the Go Playground. If you can't see how they're used and maybe learn how to use them to troubleshoot them, you tend to have issues with them. Finally, dependency management and knowing how to work with your packages is also not included in the Go Tour or the Playground. Modules is a workflow and tooling issue, because when you're pulling down dependencies, you're doing it so over the wire and you need network connectivity. So what this is doing, or what this is asking of us, is to move beyond teaching the language, and it's not enough to teach the language. You have to teach the end-to-end experience and the daily workflows. Today, I'm happy to announce a solution. Through Google open source sponsorship of the community, playwithgo.dev is launching. Playwithgo.dev is an interactive learning environment that's meant to supplement the Playground and the Tour. It helps not only students, but trainers and teachers to get to the meat of a subject matter without fiddling with installation and system dependencies. Moreover, it's not just a community of end users and learners, but intended to serve as a community of content creators too. Playwithgo.dev helps you write your own interactive tutorials for the community, by the community. For the budding content creators, there's even a guide to help you write tutorials. Head over to Play with Go on Gopher Slack to learn more. Because I'm the person that has to finish adding all those green check marks before moving on, let's recap. We've spent a lot of time improving the diffusion and the innovation in language itself to meet the needs of developers. Through Go.dev and the package Go.dev, which is the Go discovery site, we've provided a social system with transparency and discoverability that demonstrates a robust Go ecosystem in helping enterprises choose Go for their tasks. And finally, we've addressed tooling, workflow, and learning best practices by introducing a community-led, community-owned interactive learning platform where anyone can build a guide so we can empower everyone to diffuse best practices in Go. I want to address the last, perhaps most important point on this mainstream market as it pertains to social systems. When we say mainstream developers, we also have to include the broader society at large. This is vitally important. As Russ Kosk said in a keynote 5 years ago at GopherCon, we need everyone, and everyone's not here. This means recognizing, broadening our understanding of those who want to come to Go and cannot. What's missing? This recognition that there are broader societal factors that hinder diffusion and adoption, especially if it's somebody that wants to become a Go developer. These factors include marginalization, current power structures, closed social networking, prevailing attitudes, and biases that actively exclude people. We need to move beyond pragmatists, conservatives, and skeptics, because all of this still assumes privilege, access, and agency to learn and use a programming language, all on their own. So, in the coming weeks, our partner GoBridge, with support from the Go Developer Network, is going to announce a mentorship platform that matches mentors to mentees. If you're a mentor looking to give back, or someone needs help in leveling up their Go, stay tuned to Golang Bridge Twitter in the coming weeks for more details. I leave you with this, our next million Gophers, those that we want to be reflective of the global population. This is the future adoption and the future diffusion that we want, where anyone who wants to learn Go can get the help they need, help others in turn, and power our digital infrastructures to help solve the next decade of challenges: climate change, pandemics, systemic oppression, inequality, through the bytes and bits that connect us to our work and connect us all. Thank you.